going to discuss, that is states of matter introduction. Good morning everyone. Today we are going to discuss, that is states of matter introduction. See, states of matter we can divide that gas state, liquid and solid states. Gas state, when the molecular force of attraction between the particles of a matter are minimum, the particles exist in a state known as gas state. Once again I am repeating, when the molecular force of attraction between the particles of a matter are minimum, the particles exist in a state known as gas state, or a state of matter in which molecules are far away from each other and free to move in available space is called gas state. Gases state. Then properties of gases. Properties of gases, they do not have definite shape and volume. Then second point, they can occupy whole space open to them. The next third point, gases have unlimited dispensability and high compressibility. Then another point, they have very low density because of negligible intermolecular forces. Gases exert pressure on the wall of the container with perfectly elastic collisions. Then last point we can say, they diffuse rapidly through each other to form homogeneous mixture against the electric, magnetic and gravitational field. Then what are the parameters of gases? The characteristic of gases are described in terms of four measurable parameters, and it is also called as measurable properties of gases, which are as follows, that is mass. First parameter is mass, second parameter volume, third one is pressure, and the temperature. Second one is the temperature. Then what is the parameter of mass? Mass is equal to 1 kg is equal to 10 to the power of 3 grams. Number of moles of gas, N is equal to, we can say, mass in gram upon molar mass. Mass in gram is, it is denoted small m. Molar mass is denoted capital M. Then volume of any sample is considered to be the space of the container that it occupies. 1 liter is equal to 1000 milliliter. See, 1 liter is equal to 1000 milliliter. 1000 milliliter is equal to, we can say, that is the 10 to the power of 3 centimeter cube and is equal to decimeter cube. Then 1 milliliter is equal to 1 centimeter cube, we can give, that is equal to 10 to the power of minus 3 liters. Then 1 meter cube is equal to 10 to the power of 3 decimeter cube, that is equal to 10 to the power of 3 liters, is that equal to 10 to the power of 6 centimeter cube. Then pressure, next term is pressure. It is defined as force per unit area of a gas which can exert pressure equally on the walls of the container, the air surrounding, and earth exerts some pressure on the surface, which is called atmospheric pressure. Gaseous pressure is measured by means of a device called manometer. See how we can measure. Gaseous pressure is measured by means of a device called manometer. What is the equation of pressure? Pressure is equal to force upon area. Then force, nothing but force, we can say force is equal to mass into acceleration upon area. Then that is equal to milligrams upon area, where m is the mass and g is the acceleration due to gravity. Like we can say standard pressure is 1 atmosphere and is defined as the pressure exerted by exactly 76 centimeter or 760 millimeter of mercury at 0 degree Celsius. 1 atmosphere is equal to 76.0 centimeter of Hg, that is equal 760 millimeter of Hg is equal to 760 torr. 760 torr. That is 1 millimeter of Hg is equal to 1 torr. Then next older unit of pressure is bar. Then 1 bar is equal to 0.9862 atmosphere is equal to 1 atmosphere. SI unit of pressure is Pascal. It is defined as the pressure exerted by a force of 1 Newton on the area of 1 meter square. Then next pressure is equal to mass into acceleration upon area. Then mass is 1 kg if you are thinking, then acceleration 1 meter second square upon meter square area. Then finally we can say 1 kg meter inverse and second inverse, that is called 1 p. 1 atmosphere is equal to 101325 Newton meter square. Then Pascal is equal to 101.325 Kelvin. Pascal is equal to 10 to the power of 5 Pascal. The next temperature, next term is temperature. See, temperature is expressed in centigrade or Celsius scale, 0 degree Celsius, and Fahrenheit scale of temperature. Centigrade scale and Fahrenheit scale of temperature are related as 0 degree Celsius is equal to 5 by 9 degrees Fahrenheit minus 32. Like temperature below minus 273 degrees Celsius cannot be realized. This had to another scale called like Kelvin scale, in which minus 273.15 degrees Celsius is taken as 0 Kelvin, 0 Kelvin, called absolute zero temperature. Minus 273.15 degrees Celsius is equal to 0 Kelvin. Then at absolute zero temperatures, what is the absolute zero temperature? Here we can say, like first point we can say that is kinetic energy of the gas is 0. Then second one, pressure of the gas is 0 as all molecular motions cease. Then next third one, heat content of the gas is 0. Then another one is volume of the gas is 0. Here important point, that is you have to remember that note standard or normal temperature pressure for any gases conditions are P is equal 1 atmosphere, that is equal T is equal 0 degree Celsius, that is equal 273 Kelvin, that is 273 degree Kelvin. Here there is numericals are there. Numericals we will explain another live classes, like I will take definitely. The next first one is Boyles law. See, Boyles law very very important. Boyles law always that is based on equations. Why we can say at constant temperature and at constant temperature and fixed number of moles, volume is inversely proportional to pressure. Volume is inversely proportional to pressure. It is known as Boyles law. It states that, even generally we can give, it states that for a given mass of a gas at constant temperature, the pressure is inversely proportional to its volume. Even we can give this definition also. Boyles law definition, it states that for a given mass of a gas at constant temperature, the pressure is inversely proportional to its volume. Even another definition we can give, like we can say at constant temperature and fixed number of moles, volume is inversely proportional to pressure. It is known as Boyles law. Then this formula we can give like V inversely proportional to 1 upon P. Then PV is equal constant. Then P1 V1 is equal P2 V2. Then at a constant temperature, product of pressure and volume of a gas, a given mass of a gas is constant. Like we can say that graphical representation like x-axis and y-axis if you take, like this is x and this is y-axis if you take, then pressure is y-axis and volume is x-axis if you take, then 1 by v, p versus 1 by v, then pressure and volume if you take x-axis y-axis, then pressure is taking only pressure is x-axis, then pv versus p is, it will be straight line, then volume is x-axis, y is volume is, if you take y-axis, then pressure is x-axis, then it will come curve line it will show. Like we can say, these curve plotted at fixed temperature are known as isotherms. First graph shows that 1 by v increases according to increase in pressure, then second graph shows that the product of pressure and volume remains constant. That is, third graph shows that with the increase in pressure, volume decreases. Then what are the significance of Boyle's law? What we should remember this Boyle's law. Air at the sea level is dense because it is compressed by the mass of air above it. Then second one, the density and pressure decrease with increase in altitude. Then third point, that is, the decrease in pressure at a high altitude causes altitude sickness because of decreased oxygen intake in each breath. Then relationship between density and pressure. According to Boyle's law, that is V inversely proportional to 1 by P at a constant temperature. See, relation between density and pressure. According to Boyle's law, V inversely 1 by P at a constant temperature. Again, V inversely proportional to 1 by D. Why? Because inversely proportional to D, where D is the density, V is equal mass upon D. 1 by D inversely proportional to, like directly proportional to 1 by P, or D directly proportional to P, where T is constant. Then we can say D1 upon P1 is equal to D2 by P2. That is Charles' law. Mathematical expressions, we can say that. Boyle's law, mathematical expressions. Then next, Charles' law. Charles' law, at constant pressure, the volume of a given mass of a gas increase or decrease by 1 by 273 of its volume at 0 degrees Celsius for every rise or fall 1 degree in temperature. Also, the volume of a given mass of a gas is directly proportional to temperature in Kelvin at constant pressure. Then V T is equal to V naught plus V naught upon 273 into T at constant pressure. Then Vt is equal to V naught 1 plus T upon 273. Then Vt is equal to V naught 273 plus T upon 273. Then let 273 plus T temperature, then that is called absolute temperature, and 273 is equal to T naught. Then V1 by T1 is equal to V naught by T naught at constant pressure. Like we can say, alternately, the volume of given mass of a gas at constant pressure is directly proportional to its absolute temperature. That is V1 by T1 is equal to V2 by T2 at constant pressure. Then what are the graphical representation here? Charles' law, and what are the significance of Charles' law, and what are the relation between density and temperature. Say, significance of Charles' law, there is first point is volume of the gas increases on heating, hence its density decreases. Then hot air is less dense than cold air. Then third one, based on this principle, hydrogen balloons and hot air balloons are still used for weather observations. Then next, relationship between, like we can say that relationship between density and temperature. Then according to Charles' law, V directly proportional to T. That means volume is directly proportional to temperature. Like we can say, at constant pressure and fixed number of moles, volume of gas is directly proportional to temperature. It is known as relation between density or temperature. Like we can say 1 by d, inversely or like directly proportional to t, then t1 is equal to t2. That is Charles law above. Then next, if you take graph, Charles law graph, x-axis is temperature and y-axis is volume, then always it is straight line. Actually minus 273 degrees Celsius is absolute zero, absolute temperature. That absolute, from absolute zero, from absolute temperature to it will go straight line. Okay, graph is, it is always straight in Charles law. The next, Gay-Lussacs law. Gay-Lussacs law or Amonton's law. Gay-Lussacs law or Amonton's law. It relates the pressure and absolute temperature of a given mass of a gas at constant volume, then volume remaining constant. The pressure of a given mass of a gas increases or decreases by 1 by 273 of its pressure at 0 degree Celsius per degree change of temperature. Then P is equal to P plus P multiply with T upon 273. Then Pt is equal to P naught of 1 plus T by 273. Then Pt is equal to P naught 273 plus 1 T upon 273, that is called P naught T by T naught. Then we can write finally P is directly proportional to T. Gay-Lussacs law. We can give like, it states that P directly proportional to T means we can, what is the, it states that volume and number of moles or fixed number of moles are here constant. At constant volume and fixed number of moles, pressure is directly proportional to temperature. It is known as Gay-Lussacs law or Amonton's law. Like at constant volume, the pressure of a given amount of gas is directly proportional to its absolute temperature. Then next, Avogadros law. Avogadros law, equal volumes of all gases under the similar conditions of temperature and pressure contain equal number of moles, that is V directly proportional to N. That means at constant pressure and temperature, number of moles of gas or volume of gas is directly proportional to number of moles. It is known as Avogadros law. Here what are the terms are constant? T and P. P pressure and T temperature constant, then V directly proportional to N, that is Avogadros law. The next, the law is applicable only at a very low pressure, hence it is called limiting law. Limiting law, that is why Avogadros law we can say limiting law also we can say. Then next, molar volume. The volume occupied by 1 mole of an ideal gas at STP standard temperature pressure is equal to 22.4 liter is molar volume. Then next, what are the ideal gas equation? Ideal gas equation, the equation that gives the simultaneous effect of pressure and temperature on the volume of a gas is known as ideal gas equation or equation of state for an ideal gas. Then various forms of ideal gas equation, that is P1 V1 is upon T1, P1 V1 upon T1, P1 V1 upon T1 is equal to P2 V2 upon T2. Then where R is universal gas constant or molar gas constant, it does not depend on the nature of the gas or conditions of temperature. Then R is called PV upon T for molecule force upon area multiply volume upon temperature. Then that is called force into length upon temperature. Then that is called work energy upon temperature. Then units of R. What is the universal gas constant units? That is 0.0821 liter atmosphere and Kelvin inverse and mole inverse. Or another point, that is 0.8.314 joule Kelvin inverse mole inverse. Or another one, 1.99 calories and Kelvin inverse and mole inverse, or 0.002 kilocalories Kelvin inverse and mole inverse, then 8.314 Newton meter Kelvin inverse and mole inverse, then relation between density and molar mass. Then here from ideal gas equation, relation between density and molar mass, here P is equal to nRT upon V, then that is equal to m by small m upon capital M, that is called R, capital R and capital T upon V. Then number of moles N is equal to m by m, then P is equal to small m by capital M, then that is into RT upon capital M. PV is equal to dRT upon V. Thus density of the gas is directly proportional to its pressure at constant pressure, at constant temperature. See, we can give this finally ideal gas equation. Thus density of the gas is directly proportional to its pressure at constant temperature, at constant temperature. Then next another one, that is we can give Dalton's law of partial pressure and Graham's law or Graham's diffusion law applicable for effusion also. Okay, I need to modify that introduction, and Dalton's law, Graham's law also we need to add. Okay, have a nice day, thank you. Then we are going to give once again spiritual videos, and kindly join if you want to listen. Okay, thank you, have a nice day.